Hello, today we're going to take a look at complex numbers. So, complex numbers I once had described to me as a way to cross a bridge. So, we've always heard that you can't take the square root of a negative number, and that's true. You can't take a square root of a negative number and get a real number, but you can take a square root of a negative number and get an imaginary number. What this enables us to do is this creates a bridge for us to cross over so that we can do further things with square root of negative numbers and be able to perform operations now with imaginary numbers. So don't get confused. They aren't a real number. It's still technically not something you can do to get a real number, but now we can look at them and say, well, we can get an imaginary number if we take the square root of a negative. And so what we've got for an imaginary number is the fact that I squared is equal to negative 1. So I squared is equal to negative 1. If that's true, then that means that the square root of negative 1 is equal to I. Okay? This enables us to cross that bridge over into imaginary numbers. So anytime you have the square root of a negative number, then we would bring out an I as the square root of that negative and be left with B underneath. So if you have square root of negative 3, then that would be the same thing as I times the square root of 3. So here's some examples. A says the square root of negative 25. Well, what this means is this is the square root of negative 1 times the square root of 25. We know the square root of negative 1 is I, and we know the square root of 25 is 5. So there's our answer, except for we like to rewrite it as 5I instead of I5. For the next one, square root of negative 12, that's the square root of negative 1 times the square root of 3 times the square root of 4. I'm going to rewrite that as the square root of 4 times square root of 3, just to put things in a better order. Okay, so square root of negative 1 is I. The square root of 4 is 2. And the square root of 3 is just the square root of 3, because we're leaving this as an exact number, not changing them to decimals. So rewriting this, we have 2I square root of 3. And last, for part C, the square root of 13, that's the same thing as the square root of negative 1 times the square root of 13. Square root of negative 1 is I, and the square root of 13 is just square root of 13. So notice when we are able to take the square root, we put it before the I. When we're not able to take the square root, we put the I before the square root. So we have I square root of 13. Let's look at simplifying these. So we have I to the 48th power. What we want to do is we want to get this down to either an I, a negative I, a 1, or negative 1. We can actually simplify them down to one of those four things. So we know that I squared is negative 1. And if we take I squared and raise it to the 24th power, that's getting us I to the 48th. So now we can plug in negative 1 for I squared and raise that to the 24th power. Well, any negative number raised to an even power is going to give us a positive number. Just like if you've got negative 1 squared, that's negative 1 times negative 1 gives you a positive 1. So we end up with a positive 1 here as our solution. For part B, This time we've got a odd exponent. So what we're going to do is we're going to say I to the 22 times I. That gets us an even exponent, so we can do the same thing we did with part A, and then we just got times I out there on the end. So I to the 22nd power is the same thing as I squared to the 11th power. Then we can plug in -1. -1 to the 11th power, any negative number to an odd power will give us negative, like -I cubed would be -I times -I times -I, which give us -I. Okay, so -1 to the 11th power will be -1. And -1 times I is just -I. For C, this time we've got an even exponent again, so we can say I squared to the 25th power, because 2 times 25 is 50. Plug in our -1, excuse me, and -1 to an odd power will give us -1. And then last, we've got an odd exponent again, and it's negative. So this is the same thing as 1 over I to the 19th. Remember your exponent rules. So we can say that that's 1 over I to the 18th times I. Now we can plug in I squared on the bottom. So we'll have I squared to the 9th power times I on the bottom. I squared is -1. And we're going to have to bring this up here. -1 to the 9th power will give us a -1. So we've got 1 over -I. Well, you've always heard that you can't have a square root on the bottom of a fraction. That's also true with an I. We can't have an I on the bottom. So in order to, quote, rationalize our denominator, we're going to multiply by I over I. And we can do that because I over I is 1. So we'll get an I on the top. And on the bottom, we get -I squared. We know that I squared is -1, so that'll give us -1, which is a positive 1. So finally, our answer is just I. Complex numbers are written in terms of I. They can have a real component and an imaginary component. So you may see the number 2 plus 5I. 2 would be your real part, and 5 would be your imaginary part. Simplify this, write it in the form A plus BI. Now, these follow the same rules of addition, subtraction, multiplication, and division that we've always used. So here, we're just adding and subtracting, and so we're going to combine like terms. So really all you've got here is -2 minus 4I plus 5 plus 2I minus 3 minus, we got to distribute the negative, minus 3 plus 6I. Okay? And so we'll combine our like terms. We've got -2 plus 5 minus 3. That actually gives us 0. And then -4I plus 2I plus 6I will give us 4I. So our answer is just 4I. We don't need to worry about having the 0 on there. For example 4, we're multiplying these two, and we'll do it just like we always have. We're going to full. So we'll have negative 2 times 4 gives us negative 8. That was the first. And then outer. So negative 2 times negative 3i gives us 6i. Inner. 6i times 4 gives us plus 24i. Need to move this down a bit. And then last, 6i times negative 3i gives us negative 18i squared. So we've got a 6i and a 24i that we can combine to give us 30i. And if you'll remember, I squared is negative 1. So negative 18 times negative 1 is positive 18. Now we combine the 18 and the negative 8 to give us 10 plus 30i. Here we've got 3 plus 4i, quantity squared. Remember, that means the same thing as 3 plus 4i times 3 plus 4i. Don't try to do 3 squared plus 4i squared. That doesn't work. We're going to full here again. So 3 times 3 is 9. Then 3 times 4i is 12i. 4i times 3 is 12i. And 4i times 4i is 16i squared. Combine the like terms in the middle. Remember that I squared is negative 1. So that gives us minus 16. So 9 minus 16 is negative 7 plus 24i. Again, we're going to full here. So 5 times 5 is 25. 5 times negative 2i is negative 10i. 2i times 5, oops, sorry about that. 2i times 5 is positive 10i. And 2i times negative 2i is negative 4i squared. Our 10 i's in the middle go away. I squared is negative 1. So we have 25 plus 4, which is 29. Now there's something I want to point out about this. Notice this is 5 plus 2i times 5 minus 2i. What we've done here is we've multiplied by the conjugate. We'll do that later on, just as we did with roots, in order to simplify and get rid of i's on the bottom of a fraction, okay? So notice that when we multiply by the conjugate, we get rid of the I altogether. So that's important to notice here. And here's that rule that if we have a plus bi times a minus bi, that is a squared plus b squared. Notice no i's. So for example 6, if we want to simplify this to get rid of the I on the bottom, then we've got the conjugate of 3 minus 5i is 3 plus 5i. So we're going to multiply the top and the bottom by 3 plus 5i. So FOIL on the top, not going to write out every step here. We get 24 plus 46i plus 10i squared. On the bottom, 3 squared is 9. And I think that should be a minus. Oh, I see. It's a plus because of the I squared being negative 1. Okay, so we have 9 plus 5 squared is 25 on the bottom. Keep in mind that this is negative 1. So 24 plus negative 10 gives us 14. And on the bottom is 34. Now, we do need to simplify this if we can. In this case, all these numbers, 14, 46, and 34, are divisible by 2. So we're going to divide each of these by 2 in order to simplify. So we'll have 7 plus 23i over 17. And that's as far as it can go. There's 2 ways that you can write this answer. You can leave it like this. Or since it's asked to be written in the form a plus bi, then we need to separate things. And the same thing would be 7 over 17 plus 23 over 17i. So be careful about which way it asks you to write the answer. In this case, this would be your correct answer, even though the previous one means the same thing. For example 7, we're going to solve this using the square root property. So, just like usual, if we're going to solve this for x, then we would subtract 36 from each side and then divide by 2. And then take the square root of both sides. And notice that gives us plus or minus the square root of negative 18. So that gives us the square root of negative 1 times the square root of 9 times the square root of 2. So simplifying this, we've got positive or negative. Square root of 9 is 3, so 3. Square root of negative 1 is I, and then we just have square root of 2 left. So our solution set is negative 3i square root 2 and positive 3i square root 2. Let's look at another one. This one we're going to have to use the quadratic formula to solve. I'm going to start this off by getting rid of our fractions, because if we can get rid of them, it'll just make things easier. If we multiply through by 10, then that's going to help us out here. We'll just be left with 3x squared on the top. For 2/5 x, if we multiply by 10, then 2 times 10 is 20. 20 divided by 5 is 4x. And then for 7/10, it just gets rid of the 10 on the bottom. And this one does not factor. We could try it, but I already know it doesn't. So let's use the quadratic formula. Of course, that's what it told us to do, didn't it? So x will be negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. 4 squared minus 4 times 3 times 7 is negative 68. So we've got negative 4 plus or minus I times the square root of 8 over 6. Now that square root of 68 can be simplified. If you want to just go to the side somewhere, make a tree for it. Let's see, 4 times 17 gives us 68. And square root of 4 is 2. So this will give us negative 4 plus or minus 2i times the square root of 17 over 6. We're not quite done because, again, we have negative 4, 2, and 6 are all divisible by 2. So we're going to divide all these by 2 in order to simplify a little bit more. Negative 2 plus or minus I square root of 17 over 6. So that's one way we could write our answer. Or if it's asked to be written in the form a plus bi, then the same thing would be, on the bottom, that should be a 3. Sorry about that. So the same thing would be negative 2/3 plus or minus I square root of 17 over 3. The last topic we're going to discuss today is something called the discriminant. The discriminant is when you've got something in quadratic form, b squared minus 4ac. Now, that should sound familiar. That's that thing that's underneath the square root for the quadratic formula, b squared minus 4ac. And it's called the discriminant. If we went through and solved several equations using the quadratic formula, then we would find the results that we've got listed here. Let's go back and look at this one real quick. When we did b squared minus 4ac in example 8, we got a negative number. Notice, since we got a negative number, we ended up with non-real solutions. Solutions that had an I in them. So whenever, that's one of the rules for the discriminant, if your discriminant is negative, less than 0, then you have 2 non-real solutions. If the discriminant is equal to 0, then you have 1 real solution. And if the discriminant is greater than 0, then you have 2 real solutions. If we look at this in terms of our parabolas, because that's what a quadratic graphs as, then 2 non-real solutions means we have a parabola that does not cross the x-axis. 1 real solution means that we have a parabola that just touches the x-axis. And 2 real solutions means that we have a parabola that goes through the x-axis and back through again. So for the last example, we're just going to use the discriminant to determine the type and number of solutions, and that's it. So, negative b, or excuse me, I'm just trying to do the whole quadratic formula. Just b squared minus 4ac. So b squared minus 4 times a times c. That's 9 minus 20, or negative 11. So since we have a negative answer, that means we have 2 non-real solutions. It doesn't ask us to find them, just to tell us how many and whether they're real or not. Then part B, the first thing we need to do with this one is put it in order. So we got 2x squared. I'm going to add 6x to both sides and subtract 3 so that we're set equal to 0. And now we've got it in ax squared plus bx plus c form. So b squared minus 4ac. And that gives us 60. It's a positive number, So that means we have two real solutions. And last, again, we need to put this one in order. So we've got 4x squared plus 12x. Get that negative 9 over by adding it. So plus 9 equals 0. B squared minus 4ac gives us 0. So that means that we have one real solution. Okay, I lied. There is a little bit more we got to do. Sorry. So, example 10 wants us to solve these two equations using U substitution. So, as you can see, if you look at this, it's pretty complicated. But what I want you to be able to pick out is that you've got something squared. So, ax squared plus something, a number, times that same something, so bx, plus another number, okay? So ax squared plus bx plus c is happening in this equation. Only our x is much more than x. So we use what's called U substitution. We're going to let U be what's in this parentheses here. And if we do that, then we can just say U squared minus 36U plus 35 equals 0. And now we have a simple quadratic that we can solve. So first thing we do is we solve for U, and then we're going to go back and solve for x. But let's start with solving for U here. This one can be factored. It'll be U plus 35 times U plus 1. So we set U plus 35 equal to 0 and U plus 1 equal to 0. So U is negative 35 or negative 1. Okay. Well, so we've found U, but we've not found x. So please realize that you're not done here. So what you're going to do is you're going to take what we let U be 2x squared minus 3, and plug it back in for U here. So 2x squared minus 3 equals negative 35, and 2x squared minus 3 equals negative 1. Now we can solve both these equations for x, and then we'll be finished. So on the left, let's start by adding 3 to both sides. Then divide by 2. Take the square root of both sides. And so that gives us that x is positive or negative 4i. For the right-hand equation, add 3 to both sides again. Divide by 2. And take the square root of both sides. So x is positive or negative 1. So our solution set is negative 1, positive 1, also negative 4i and positive 4i. Let's look at one more of these with U substitution. Just to make sure we've got plenty of examples in here. Okay, so this one, first off, isn't written in the correct order, so let's do that. We got to get everything set equal to 0. So we've got 2x to the 2/3. I'm going to subtract 3x to the 1/3 from both sides and subtract 20 from both sides, and we have it equal to 0. Now, how is this lending to be ax squared plus bx plus c? Well, if you take this little guy here and realize that this is the same thing as 2x 2 times x to the 1/3 squared. And that was supposed to be a 3. Then you can see now that we've got the same thing here and here, and it's in the form ax squared plus bx plus c. So our u is going to be x to the 1/3 power. So we have 2u squared minus 3 times u minus 20 equals 0. This one can also be factored. You could use the quadratic formula if you like, but you could take this to the side and factor it, which is something you're expected to know how to do by now, so I'm not going to go through that. But it factors to be 2u plus 5 times u minus 4. Now we'll set both of these equal to 0. Subtract 5 from both sides and divide by 2. And u is negative 5/2. And over here, add 4 to both sides. So now we've solved for u, but again, we're not done. We have to get x. Okay, we said that u was equal to x to the 1/3 power. So we're going to plug in x to the 1/3 power for each of these equations. Now, how do we get rid of the 1/3 power? We raise to the third. So we're going to raise both sides of our equation to the 3rd power. That gives us x over on the left. And we're going to, when we raise negative 5/2 to the 3rd power, we are cubing both the 5 and the 2. So negative 5 cubed is negative 125, and 2 cubed is 8. Then we'll do the same thing with this other equation. We're going to raise both sides to the 3rd power. 4 cubed is 64. So our solution set is negative 125 over 8, 64. And now that concludes our section on complex numbers.